It says a rectangular box which is open at the top could be made from an 18 by 24 inch piece of metal by cutting a square from each corner and bending up the sides. So they're talking about the dimensions of the metal here being 18 by 24. This is like before any cuts get made. So basically that's a 24 and that's a 18. But then they're saying that they'll cut squares out of the metal at the corners like this. The size of the squares could vary. And then what they're going to do is they're going to fold up along these seams here. Removing this part of the metal and then folding up. They're trying to make this shape. Yeah, so the final result's supposed to look like that. And we gotta write down what dimensions this thing would be. But first, let's keep it general. We don't know the size of the square that they're gonna cut out, so I would call that an x by x square. And that dimension is gonna be the same all the way around. So what that means is that this section ends up being 18 minus 2x, and this dimension here will be 24 minus 2x. That's because you got an x here and an x there, and the whole thing was said to be 18. So that means that this section must be 18 minus 2x. And then this part would be 24 minus 2x. So our final dimensions, 24 minus 2x, 18 minus 2x, and then the height of the thing is x. Talking about the part that got folded up being x. So we can make a volume in this problem as a function of x by doing the length times the width times the height. But see, the length is 24 minus 2x, and the width is the 18 minus 2x. So I'm going to take these formulas and substitute them in, and then finally also the x. So yeah, we're just going to multiply all these three things together. So you got 24 minus 2x, 18 minus 2x, and x. I'm going to FOIL this, doing firsts, outers, inners, and lasts. Okay, we'll get minus 36x minus 48x plus 4x squared all times x. Distribute the x. Now let's find the derivative of the function. Set the derivative equal to 0. And now we'll solve for x. I'd rather make things easier. Dividing all terms by 12, they share that as a common factor. 36. When the numbers are small enough, you may be able to factor it. 36 though, his factors would be 6 and 6, 9 and 4. Nothing seems to work there. 12 and 3 doesn't really work. I'm going to use the quadratic formula. Okay, so x should be negative 14 plus or minus square root negative 14 squared minus 4 times 1 times 36 over 2 times 1. Yeah, it doesn't come out to a nice number. So we could look at the original formula and see which root is going to be better. Is it going to be 14 plus radical 52 over 2 or 14 minus radical 52 over 2? Let's see. Here's our objective function. So clearly there are two extreme values. There's a peak here and a minimum, a valley there. This is a function for the volume, so obviously this one on the right is not realistic. Only this one is realistic, the 3.39. Now, let's see what these come out to. Okay, so one of the results is 10.6, that's this one. And the other is 3.39. So just by looking at the objective function, this is not the correct solution. This one is. Now we know that the side of the square that's cut out needs to be about 3.39. They're asking me to find the dimensions of the box with the greatest volume. So the height obviously is 3.39. Now we have to find the length and the width. So we'll just substitute back into the length and width formulas then. So your length needs to be 24 minus 2 times 3.39, which is about 17.22. And your width needs to be 18 minus 2 times 3.39, 11.22. So these are going to be our final dimensions.